So, hello to all my young friends who are studying in intermediate and they are watching this video. Welcome to this series of Calculus Made Easy. In our earlier video, we had discussed about the introductory part of calculus as to what is calculus. And before starting the subject, we are discussing some definitions which are very important and they are extensively used in calculus so that you do not get confused there. They should be clear in your mind because they may seem simple, but many people do get confused there. So I request you to watch this carefully. So today we are going to discuss intervals and neighborhoods. So what is an interval? So in mathematics, interval is a set of real numbers lying between any two numbers. For example, if I depict a real numbers set from minus infinity to plus infinity, and we have two real numbers m and n. So all real numbers lying between n and n is called the interval. So all numbers which are lying between these m and n, this set is called an interval. For example, if we have 0 and 1 as an interval, so all the real numbers lying between 0 and 1, this is called the interval. The set of all numbers which are lying between 0 and 1. Now, as you all can easily make out that these all will be fractions because since they are lying between 0 and 1, so this is a set of all fractions. Now, interval may be of finite length, it may be of infinite length. So let us discuss the types of finite length intervals and infinite length intervals. What is finite length interval? If a and b belong to real numbers and a is less than b. Suppose we depict the real number like this from minus infinity to plus infinity, and we have a here and we have b here. You can clearly see that a is less than b. So finite length interval means all set of all numbers lying between a and b, but here there can be four conditions. Now any number which lie between a and b is a member of that set, of that interval. Now how do we denote this interval? We say we can denote it by this method, and there can be four cases. One is x belongs to real number and x lies between a and b, and in this case x is greater than or equal to a, less than or equal to b. That means a and b are included in this interval, right? Because a is also included because that x can be equal to a also, and it will be greater than a, and x can be equal to b. So we write it like this: a, b. Since a is included, we put this kind of bracket, right? So this is denoted by this bracket, and this type of interval is called closed interval because that both the ends interval is closed because end values are included. A and B are included. So this is one case. Case 2, X lies between A and B, but it is neither equal to A nor equal to B. That means A and B are not included in this interval. So we'll write like this: A, B, and this kind of bracket. So this kind of bracket means neither B is included nor A is included here. This is denoted by AB, what I discussed, and this is called open interval. So this interval is open. And earlier, if A and B are included, then we have discussed this is closed interval, right? Now there are two more cases. Case 3, if X lies between A and B, X is less than B but is greater than or equal to A. That means A is included. So we'll put this bracket on the left hand side, but B is not included. So we'll put this bracket. That means this is open at this end and closed at left end. Or it can be X lies between A and B, greater than A but less than or equal to B. That means we will write it like this. On left it will be open, but right it will be closed. So it is open at one end, closed at one end. So we have discussed these four types of finite length interval. This is closed, this is open, this is closed and open, closed at one end and open at one end. But these all are finite length intervals. Now, what is infinite length interval? If X lies between A and infinity, here also, suppose this is A, that means X, any number which lies between A and infinity, is a member of this set, that interval. Although I have depicted here, but we cannot depict infinity. That is the reason I have put this dotted line, because infinity doesn't have any value. So we cannot depict it. Just to show you, for your understanding, I have put plus infinity and minus infinity on this side. Now, here again, there are two cases are possible. Case 1, if X lies between A and infinity, but X is greater than or equal to A. That means we will write this interval like this. At A left hand, it is closed. But on the right hand, we will always keep it open. It's very important. Why? Because infinity is not defined. So after infinity, you can never put this open, closed end. If it is infinity, you will put always open end. And if it is minus infinity, there also you will put open end. Please note this, this is very, very important. Why? Because infinity is not defined. So this interval is denoted by A infinity, what we discuss. Other cases, X is greater than A and less than infinity. So we also cannot write X is less than or equal to infinity. We cannot write, because equal to we cannot write about infinity because infinity is not defined. So in this case, also we will write open end on the right side. On left side also it is open because a is not included in this interval.